Shapes on the coordinate plane, lesson 20. We're going to use the coordinate plane to solve some problems and puzzles. And today's I can find the lengths of horizontal and vertical segments in the coordinate plane. I can plot polygons on the coordinate plane when I have the coordinates of for their vertices. So make sure you have today's date, your ICANs, and you are ready to move on. All right, let's do a little warm up here on coordinate plane and figures on a coordinate plane. So let's review some of this real quick. What's a vertice? A vertice is where you have two or more lines coming in to the same point. Usually call it something like a corner or something. Parallel sides, what does that mean? Yeah, the sides are completely equal to each other as far as their distance from each other. It doesn't mean they're the same length, but it does mean that they stay apart by the same amount and that they never cross. And a right angle means that it's a 90-degree angle. So if I'm going to draw a figure with 6 vertices, one pair of parallel sides, and at least one right angle, and 2 of the sides the same length. Oh, I gotta have at least 3 of those properties. All right, well. And you could do this pretty easily on your own. Just would need some paper and a pencil. All right, so I got my 6. And since I made a regular hexagon, my opposite sides are parallel, and I made all the same lengths. I did not make right angles, but I did get the other 3. And then remember that when you talk about polygons, polygon has to be a shape, and I wouldn't have had to make a regular one like this. I could have made just anything that had 6 points, or I could have just made a square, and that would have covered all of the requirements that we needed. But remember that a polygon is any closed figure with straight sides. So your squares, your quadrilaterals, pentagons, rhombuses, all the hits from elementary. Yep, they're still here. Let's plot some polygons here. So I'm going to give you the interactive where you can go through and do each one of these. So you'll need to get those points from the previous part. But all you do is you just grab for the first one. You're just going to grab, drag your points to where they go. Now, I'm not currently looking at what it's supposed to do, so I know that this is not accurate at all. And then what you can do is you can click check, and then it'll let you know how many of the points you have correct. And then to switch to the other ones, you just drag the little dragger back and forth. Okay? Let's take a few moments to work through those. So when you've gotten them all done, you should have ended up with pictures that looked similar to this. And in each case, you made a polygon with those particular ones. So works out pretty well. So how is a coordinate plane related to a number line? Let's think about that real quick. It's the same sort of thing, right? It's basically a coordinate plane is 2 number lines that cross over each other, right? And then how are we able to make the polygons on the coordinate plane? Well, once we plotted our points, it was just a matter of connecting those points to make a closed figure that was a particular type of polygon. All right, let's go with something else that's amazing. Okay, well, anyway. All right, so take a look at this diagram of this maze. And this is it shows Andre's route through this maze. He started down here on the lower right and exited up here. So what are the coordinates of the first 2 and last 2 points of his route? Well, considering that we have each of the points at 1115, either 1115 positive, both of those as negatives, one is a negative, one is a positive, and the opposite, each of the lines must be worth 2 whole units. So if this is 11, then this would be 12, yeah. Okay, so should be 12 for the x. That means this is negative 14, negative 12, negative 10, negative 8. What about this point? Yeah, so we had 10, 8, 6, 4. So this is at 4, still negative 8. And then up over here, again, if we're one further, this is negative 12. 15, this is 14, 12, 10, 8, and then we have 10, 8, 6, negative 4, and that's on the same y, so that's 8. So how far did he walk from his first, or from when he walked in to where he got? Well, let's clear those. Talking about each one of these is worth 2, right? 2 units. So we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80 total units, right? 40 squares as far as that distance, but each one's worth 2. All right. Jada went into the maze and stopped at negative 7, 2. So there's the center. So negative 7. So that's 2, 4, 6, negative 7, and 2. So she stopped there. How far is she going to need to go to get out? Oops. Did I do that right? Yeah, negative 7. She's going to need to go, let's see, 10, because that's half of that. And then to there would give us 30, 50, 70. Wait a minute. It's 2 every time. What am I thinking? That's 1, 3, 5, 7, 9, 11, 13, 15, 17 units. Unless it goes the other way, and that would be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. So it really just depends on which way you went, how that worked. All right, so if you can do this challenge, that would be fantastic, and I would love to see a picture of it. Create a drawing with a perimeter of 30 units using a continuous path of horizontal and vertical segments. So kind of like what we did back with, I guess back here, but more like the square here where we've just got vertical and horizontal, so that way it's easy for us to figure that perimeter. And then label the vertices of each one, that would be great. Would love to see it. But if you don't get to it, that's okay. All right, I think we are done for this one. Thanks for watching.